definitely be the thing I would draw here. And the reason why I think it's handy is because I think here in a second, based on the words in the question, the numbers and stuff, I think we're going to be able to put some labels on the kennel, which will help us a little bit. So here is, I think I can draw a rectangle with this. Oh, look at that. There's my rectangular kennel. Yes. How about that artwork? You guys didn't know I could draw such straight lines, did you? Yeah, been practicing. Okay, so I got this rectangular kennel. The fencing is supposed to, form the outer edge of the kennel, of course. Now let's start labeling. Does anybody see, bless you, anybody see any phrases that help us kind of understand, like, the sides of the kennel and how long things are supposed to be? I mean, like, Alec, what phrase, what words do you see?
10. If the kennel is to be 10 meters longer than it's wide.
Okay, so kennel is to be 10 meters longer than it is wide. Okay, and then it goes on to identify like what it wants us to find, right? It says, find its dimensions. So if we were going to identify kind of the unknown or unknowns in this, what would you say? Like, what are we trying to find? Yeah, go ahead.
Dimensions.
And dimensions, we could like expand that to say the width and the length, right? So in other words, how long is that right there and how long is that right there? That's really what they're asking us to do. So in an algebra situation, especially in algebra class, if something is an unknown, how do we represent it? With an x, a y, a z, some kind of a variable, right? Okay, so it says if the kennel is to be 10 meters longer than it is wide, I know the dimensions are totally unknown. So I'm going to call this one right here x, right? I don't know what it is. Yeah, it's just going to be an x. So yeah, that's what we want to get to. Like if that one is an x, how do you think we should label the other side? Because it does want both dimensions. Say again? X plus 10. Why x plus 10? Why don't we just put a y right there?
Because that has to be 10 meters long.
And that's where that phrase comes into play. We want the kennel to be 10 meters longer than it is wide. So if one side is x, the other side would have to be 10 longer than that. Longer than means plus 10, right? Make sense? Okay. So properties of rectangles, maybe be a handy thing for us to know. If you take any two opposite sides in a rectangle, what's the relationship between the sides? Equal length, right? They're the same side. So I think we could then also call this one x plus 10, and then we could call this left side x. Okay, so we got a bunch of good labeling on there. We also have that 36, right? Somebody mentioned we have 36 meters of fencing. So this is, I think, the point where we say, all right, we got 36 meters of fencing, we've got a rectangle, and we've got those dimensions that we're kind of describing up there. So how do we write like a true equation for this? Like we want to, and I'll say it again because I think it's really important. An equation has one really unique thing about it. What do all equations have, Victoria?
An equal sign.
So this has to have an equal sign. It can't just be x's and numbers and whatever and no equal sign. It's got to have some x's and some numbers and stuff with an equal sign in there. And so we want to write a true statement about this rectangle and these dimensions and everything that we can then solve and figure stuff out. Think about it. Come on, think for a second. Here's what I want you to do. I feel like there's 2 or 3 folks that are like, yeah, I think I know. I want you to think about this for a second. I want you to talk to your table partner for just a minute if you need to. But I want you to do this. I want you to write it down, okay? Or get totally stuck. One of the two, right? I want you to, if you think you've got it, write it down on your paper, and you might find out in the end, yes, that was right, or maybe that was wrong. But I want you to think about it, discuss, and write it down. Make sense? Give you just a minute or two to do that. And then we'll check and see how you did. Ready, set, go. I'm not going to answer any questions of, is this it? I want you to discuss with your table partner.
Yeah, me and Jake already discussed it.
Go ahead.
So the equation we came up with was 2 times x plus 10, so x, and then plus 2x equals 36.
Okay, so take a minute. That's what Paige and perhaps others, I don't know, came up with. She's throwing that out there. She thinks that's a good idea. Do you guys agree? Do you disagree?
I agree.
I'm hearing some agrees over here, so that's nice. Yes, Sadie.
because
Whoa.
it's basically just writing out that, but just simplifying.
Okay, so you think that you have something slightly different?
Well,
Why don't you share?
okay, well, Victoria got like x plus 10 plus x.
Okay, you kind of started and stopped. Could you start over again?
Okay, x plus 10 plus x plus 10 plus x. And that's just writing out all of that, but then that's the simplified form of that.
How should I finish that though? I mean, that's
Equals 30.
equals 36. Okay.
Oh,
Okay, so that's another suggestion. I don't know if you see any similarities there or not, Cole?
So the x's, you can combine those together. So we got 4x. You can also combine the 10. So we got 4x plus 20 equals 36.
Okay.
And then we solved it.
We'll get to the whole solving thing once we decide which, if any, of these is right. We'll get to that in a second.
Wouldn't we then have to, we did 2x plus 2x, never mind.
Okay. So, anybody have any comments on these three that we have up there? I mean, so far, those are the three proposals. Anybody have anything in addition to that or a comment on any of those? No? Do you think one of them's right and the other two are wrong?
They're all right, just they're all written.
Aren't they all the exact same thing?
Yeah,
Just written in different forms?
some of them are simplified, some of them are not.
Like this one right here, right at this point, that's the one that's most simple. But that doesn't make it any more right or wrong than any of the other ones. That's fine. What's the principle? Like, as you constructed one of these three equations, like what were you thinking about as you constructed them?
Like terms.
Okay, well, yeah, like terms when you start to simplify. I agree. But like, what was the principle behind the equation? Remember, the equation has to be true, right? It has to be a true statement about the sides of the rectangle and the 36 and everything. Like, what's the concept?
So since we solved like x for the width and x plus 10 for the length, you have to do that. You have to add them all up the four sides because then that would equal the perimeter.
Perimeter is the concept, isn't it? That's the concept of the distance around a rectangular shape like this. All you do is you add up all four sides, right? That's the perimeter of this particular shape. So perimeter was the concept. And isn't it true that every single person that suggested up there used perimeter, didn't they? They just used slightly different forms. I think you would find that if you took this and simplified it, or this and simplified it, you would end up eventually with that, wouldn't you? So I'm gonna jump off from there. To solve this, we would subtract 20 from both sides. We would get 4x is equal to 16. At that point, we would divide both sides by 4, and we would get x is equal to 4. It does ask for the dimensions. So we know that x is 4, but that's not the dimensions, right? So what are the dimensions? Yeah, so but how many meters?
Squared.
Looking for two different numbers. One of them is 4, so it's 4 meters,
Squared and 14.
and the other one is 14 meters, right? Because one of them is x, and we found out that x is 4. And the other one is x plus 10, so 4 plus 10, 14. That makes sense? So 4 meters by 14 meters, those are the dimensions on the rectangle for this particular woman. I want you to note something up there. Guys, like, you know, you guys came up with these three equations. I would expect you to, on your own paper, probably only to have one, right? Because you thought, hey, I like this one, and you went with it, right? But I want you to notice, I'm trying to be a good example for you. I want you to please take notice of this. Please see that up here on the question itself, I am marking that question up a lot, right? I'm highlighting things, I'm circling, I'm underlining. I think the action of taking your pen or pencil and like marking it up and making all the underlinings and markings, I think is a really important exercise in trying to draw the math out of the words, okay? So I would suggest you do something like that as we move forward. You guys have any questions? Did really, really well. Great suggestions. They were all good. Anybody feeling like they got a question they want to talk about? All right, well, let's do this then. Let's take a look at our next example. This one is a little bit different. And I don't know how you're going to do with this, but we'll find out pretty quickly. I'll read it to you out loud, and you guys can read along with me. It says, a youth soccer league had team names printed on colored shirts. Sounds typical, right? Maybe you've experienced this sort of thing. It was charged $18 per shirt plus a one-time setup fee of $20. If the total for all the shirts was $4,232, oh, there's a typo. It should say how many shirts, right? How many shirts were printed. Okay. So can anybody in your own words just kind of summarize the concept that's being described here? Go ahead, Ashley.
So, there's a team that has, team shirts, and you have to buy the shirt for $18 plus $20, and then the total.
Okay, that's good. I want to dig a little bit deeper on something you said. I think you described it pretty well. A team is buying shirts, and they got to pay for them, right? The team apparently, like the team as a whole is paying for the shirts. But there's isn't it weird that there's two different charges, right? Two different charges. What are the two different things that the team is being charged for these shirts? Sadie.
$18 per shirt, and then plus that total amount plus the 20.
So $18 per shirt. It's important. And then what about the 20? What did you say about the 20?
It's whatever the 18 shirts come out to be plus the 20.
So let me ask you guys an important question. I think this is an important question. I would be if these were my kids playing on this team and I was paying for these shirts, I would ask this question. So does that mean the shirts are $38 each? Fair question, right? Because 18 versus 38 is a pretty big difference, especially if you got 2-3 kids. So how does the $20 come into play as you read this? What do you think? How does the $20 come into play? Joel, go ahead.
It's a one-time fee, so you only pay it once.
Okay, so does it matter how many shirts you get?
No. So even if you buy one shirt, you still have to pay $20.
Yeah, so let me ask you this. That's kind of where I was going with this. And this would be silly because the team has more than one person, right? Bless you. If I bought one shirt under this plan, how much would that one shirt cost? $38, right? Because you'd have to pay the one-time $20 setup fee, and then you have to pay the $18 for the shirt. That would be one expensive t-shirt, in my opinion. I would never spend $38 on a t-shirt. If you bought two t-shirts, think this through for a second. If you bought two t-shirts, what would the setup fee be? $20, because it's a one-time fee, right? No matter how many shirts you order, to set up the screen printing or the design or whatever, it's $20. So if I bought two shirts, can anybody figure this out? How much would it cost me to buy two shirts? $56, right? It would be the $20 setup fee plus 18 plus another 18 to get to the two shirts. And so would it be fair to say that the more shirts you order, the less of an impact that $20 has per shirt, right? So if you order 20,000 shirts, that $20 is really not going to add up to be very much over the course of the 20,000 shirts. But if you only order one or two, the $20 is a pretty big percentage of the overall cost. Okay, so it's $18. I'm going to just kind of repeat what Sadie said. It's $18 per shirt plus, keyword there, a one-time setup fee of $20. And we know the total is right here, $4,232. I'm of the opinion, I don't know if you would share this opinion, I'm of the opinion that I don't think a picture is going to help us very much here, because what we drew a picture of a bunch of shirts, I don't see how that's going to help. That's just my opinion. If you feel like you would want to draw some kind of picture, do it, and maybe share with me what you drew. Maybe I can learn a little bit why you drew a picture. But what we want to do here is we want to take this concept of $18 per shirt and a $20 one-time fee, one-time setup fee, and the idea that we're trying to figure out how many shirts, and remember, anytime something is an unknown, how do we represent that unknown? With a variable, so the number of shirts will be a variable. We need to write an equation. And remember, what is the one unique thing about an equation? Always has an equal sign, right? That's a really important thing we don't want to forget about. Because sometimes we forget and we're just we write something, it doesn't have an equal sign. It makes a big difference. Because you can only solve an equation. You can't solve an expression. So it's got to have an equal sign. So any thoughts? I'd love to hear. Sadie, go ahead. What do you think? Say it really slow, sorry. It's early in the morning for me.
18x
Yep.
plus 20 equals
4,200 and what?
4,232.
Okay, so 18x plus 20 is equal to 4,232. Thoughts, comments on that? Yeah. Ashley. Okay, let me switcheroo here. Go ahead.
So in parentheses, I did 4,232 minus 20, and then, out of parentheses, and then divided by 18 equals x.
Whoa. Okay. That was Ashlyn's idea. Comments, thoughts on that one? Either of them, really.
A comment.
Sadie?
When you solve for the one I said, that's the same equation how you get the answer when you're doing that. That's like the process of that one.
Yeah. Ashlyn, yeah, so Sadie's identified it right. I mean, isn't Ashlyn's equation, which, it's an equation, isn't it?
Yeah.
Ashlyn's equation is basically just the solved version of what Sadie said. They're both right, aren't they? They're really both right. I guess I'm thinking, Ashlyn, did you just like pull that out? Okay, that's pretty cool. That's interesting. So you're thinking about this kind of in a backwards the normal way, but that's not a bad thing. No, Ashlyn, it's not necessarily a bad thing at all. My only advice would be this for you, Ashlyn, or maybe others that maybe were thinking the same way as her. I would be really careful with situations like this. That you're going to see one coming up where there's like 3 costs involved in a situation, and I feel like doing like if I subtract this and add this and divide by that, I feel like that could get more and more difficult. I feel like the more tried and true way of just like consistency would be the one that Sadie gave. But what you said is true. I would never say that that's wrong. And I think that it actually shows some good kind of outside the box thinking. And so let's not discount that. But I do want to go with Sadie's simply because we can now show a little process as to how we got to what you got. That makes sense? I feel like the leap that you made for some folks might be kind of hard to see. Make sense? I can see why somebody would look at yours and be like, whoa, where'd you get that? Right? And I can definitely see it. I think a lot of us can see it. But I want to make sure we go process here. So, okay. And we'll eventually see yours coming out here. So what Sadie suggested is, like I said, it's totally right. It's really, really good. We want to now try to figure out how many shirts were made. And that would be X, right? So I want to get the X by itself. And so we practiced this earlier. We warmed up with this. Obviously, there's an 18 that's right by the X, but there's also a 20 over there on that left side. Do you guys think that I should get rid of that 20 first, or should I get rid of the 18 first? Got to get rid of the 20 first. We want to move that whole term over to the right side. How am I going to move that 20 over? Subtraction, yeah. We're going to subtract the 20 from both sides. So minus 20, and that would give us 18x. The 20's add out. 42, 32 minus 20 would be 4212. That's right. So finally we're down to where we want to get rid of the 18. So I would divide both sides by 18. And what is that? Probably used your calculator. Go ahead. 234 shirts. You just did that without a calculator. Good for you. You are allowed to use a calculator if you want. So X equals 234. That means 234 t-shirts were made. Cost was $42.32. You have any questions? So is this process helping you? Are you picking these apart? Okay. Again, notice I tried to mark this question up for you, highlighted a few things, underlined a few things as I tried to bring this into math. Okay. So I think we got one final example, correct? I think it's on the next page. So here we go. Number 4. Now this one will maybe challenge you a little bit more. We saved a good one for the end of this, right? So I feel like we're going to need to spend a couple of minutes on setup here for sure. Let's read this together, and I'll see if you guys can kind of get the sense of what it means. It says the birth years of the 3 children in a family are consecutive even integers. Whew, there's a lot there. Consecutive even integers. We'll talk about what that means in a second. The sum of the integers is 5,982. Find the year of each child's birth. So when we say year, we're talking about like 1999 or 2010 10 or whatever. Does that make sense? Talking about the birth year. Wow. Okay, so there's a lot to consider here. Birth years of 3 children. So we got 3 children, so that means we need to have like 3 elements here. The unknown, what's the key word that helps us identify what we're trying to find?
The birth.
No, say it again.
Integer.
Find, right? Whoever said that. Yeah. Isn't find? So like, if somebody like makes this big long speech and at the end they say, I want you to find this, aren't they telling you in the end what they want you to actually do? Please find this. Please do that. They're giving you direction, right? So I feel like the whole first part of this question is just like, hey, we get these 3 kids, blah, blah, blah. It says find, that's a key word, find the year of each child's birth. So that's an unknown. So Lana, how do we always represent unknowns? So, yeah, there's 3 children, right? So I'm going to say, here's my first one, there's my second one, there's my third one. We can't do this because, so that makes a little more sense, right? So instead of 3 x's, because we know that they're different years, we have to use a different variable. So you could say x, y, and z. We would find that creates that's definitely better than what I had. It still creates an issue because we're going to have 3 variables instead of just 1. It's going to be, at this stage, it'd be probably impossible to solve for. And so instead of doing that, what I want to do is I want to try to relate these to each other. And the key is going to be this phrase. Well, no, you tell me. Which phrase do you think is key in order to like relate these 3 ages? What do you see? Consecutive even integers. So guys, let's take a minute and let's talk about this. This is something near and dear to my heart. My little 4-year-old is learning to count, and we're trying to teach her to count by 2s or 3s sometimes too. I mean, she's not very good at it yet, but we're just like seeing what she could do, right? If she doesn't like it, we just leave it alone. But if she's interested in it, we'll like keep like kind of pushing her to see if she likes it even more. And so this is consecutive even integers. So like my little 4-year-old, you guys can all count just fine, 1, 2, 3, 4, 5, but that's not what that's talking about, right? Consecutive, what does consecutive mean? Yeah, like one after the other. But then the word even means that all the numbers we're consecutively counting have to be even. So it'd be by 2s, right? It'd be 2, 4, 6, 8, 10, ... Okay, so what I want you to think about is the spacing between the numbers. So what is the spacing between 1, 2, 3, 4, 5, 6, 7? Isn't the spacing 1? Right? You go plus 1 to get the next one. So if you want to go even integers like 2, 4, 6, 8, 10, what's the spacing there? 2. So if the first kid has a birth year of x, then the second one would be x plus 2. That would get you to the next even integer. There is another way to do this. This is actually going to work just fine. So I'm going to say if the first kid is x, the next one is x plus 2. And then the third one is going to be a little bit different. It would be? It'd be x plus 2 plus another 2. So x plus 4. Yep. So that's how you would construct consecutive even integers. You start off with x, then you add 2, and then you add another 2, and if there's more, you just keep adding 2s to get the next one after that. Does that make sense? Did you guys have that?
Well, we did a different way. We did, I thought he was on explain.
There is another way to do this.
So we did x plus 1 plus x plus 2 plus x plus 3.
Oh, that equals 6 divided by 3, and that's 2.
Whoa, okay, now you went really fast.
Okay, so x plus 1 is the first number.
Yep.
And then second number is x plus 2.
No, that's an issue, though, because if the first number is x plus 1, and the next one is x plus 2, they're only 1 year apart. Even integers are 2 years apart.
Okay.
See what I'm saying?
We still,
We'll get there in a second, Grace.
We still got that. We did plus 1 plus 2 plus 3.
What does that even mean?
We did x plus 1.
Okay.
X plus 2, then x plus 3.
Yeah.
All of that equaled 6, and then we divided by 3, and that was 2. So
Why did you divide by?
No. So we had 3x plus 6 equals 5982, and then you subtract 6, and then you divide that number by 3.
Well, you're telling me how to solve an equation. I get that.
Yeah. So that we just simplified what we had.
Yeah.
So you think you got the right answer?
Yes.
Let's How do you know?
I did too.
Because we plugged it
2
in.
plus 4 is 6, and 1 plus 2 plus 3 is 6. Is correct.
You might have found, so, interesting. You might have found a coincidental thing that works.
Okay.
You have absolutely found a total coincidence that works. Total coincidence. Even a stopped clock is right twice a day.
Okay.
That was coincidence.
So that would be right then?
Not consistently. I mean, it sounds like maybe for this particular example, you kind of lucked into the answer a little bit. Not total luck. I mean, you're using math, of course, but that would not consistently work.
It said consecutive odd numbers.
What's the spacing between odds? 1, 3, 5, 7, 9? Still 2. Make sense?
Yeah.
Okay, Grace.
I did it a different way.
I heard you, yes.
I think
What
I
did
got
you
it
do?
right because I did the same thing on the homework that's due.
Well, let's hear it, let's hear
I
it.
got right there too. Okay, so I took 5,982 and I divided it by 3.
Oh, okay, so you're doing some, and then you went plus 2, minus 2?
No.
Okay, what'd you do?
Okay, so then I got the answer I got there, and then I added 1 to each side, added 1 to 1, and then I subtracted 1 from 1 until I got there.
So, okay, listen, you're not listening. You did some trial and error, right?
Yeah.
Not an algebra method, okay?
But,
Okay, hold on. I got to pause this. It says that, what's the other keyword? There's like one more keyword hanging out there. Sum. That's right. So it says the sum of the integers is 5982, with sum being the most important word. Connor, what does that word actually mean? Add. So we take those ages, or it's not those ages, the birth years of the kids, and we're supposed to sum them up. So the equation we would write would be x plus 2 plus x plus 4 equals 5982. Do you see the algebra there? We wrote a nice equation with variables. A, it's an equation because it's got the equal sign, and B, it's true, right? We summed them up, and apparently the sum is 5982. Okay, so the word of the day a couple days ago was simplify first. Neil, if I was going to simplify that left-hand side, what would that left-hand side look like?
So do we just add everything together?
Any like terms you can see, add them up.
Okay, so x plus x equals 2x
Plus there's one more, right?
plus 2.
No, sorry.
Oh, I see. Okay, I got it. Plus that x equals 3x.
Okay. Oh, what am I doing?
You subtract 2.
Oh, no. Simplify first. What's 2 plus 4?
Okay, 6. And then you subtract 6.
There we go. So Neil, it's possible to do it the way you were talking about. I feel it's easiest if you simplify everything. That way you have less things just sort of hanging out there that might get lost. So 3x plus 6 equals 5982. And then you said subtract 6. So we'll do that. So you end up with 3x is equal to 5976. And what's our final step? That's right. So we divide by 3 on both sides. And x ends up equaling
1992.
Ooh, these are old people. 1992.
Wait.
I don't know, is that the right answer? That sounds about right. Okay, so but that's not all of them, right? That's just the oldest one, right? So 1992 is the first.
plus 2.
The next one is 1994 because we add 2. 1996 would be the final birth year because you add another 2 to get to that one.
Wait, so I did that. I just didn't write out x equals all that.
Guys, please don't pack up yet. I know you're anxious to get moving. So hey guys, I want to be really clear about what I mean by algebra. Algebra usually involves equations that you solve. So when I was talking to Grace and saying I need to see algebra, I need to see some version of that equation. Like if you want to just like add all the x's up in your head as you're like realize, oh gosh, it's just these all added up and x plus x plus x is 3x. That's fine. So I could take the equation in the red box would work. The equation in the other red box would work. But I need to see like one of those equations in some form or fashion. And then I want to see, you subtracted 6 from both sides. Then you divided both sides by 3. When I say I want to see algebra, that's what I'm talking about. An equation that you set up that you then solved using properties of equality.
So I see where we screwed up now. So I'm just trying to make my mind remember like consecutive even numbers.
Sure.
Or integers, so when I thought what it meant by that is like integers are any number.
Not a fraction or decimal though, right? Yeah.
So like, I just thought that it would have been like an even integer by the same time. So like, is it one, going up by one is the same integer?
No, so like going up by ones will give you 1, 2, 3, 4, 5.
Yes.
Going up by twos would give you like 1, 3, 5, 7, 9, or 2, 4, 6, 8. So they're just different numbers, right? It's counting by ones or counting by twos, or it could be they're all multiples of threes. Oh, are you just going? Sorry.
So what if it says